Hello retro coding fans! Today we are going to talk about the Code Builder module of the TurboCoder 64 toolset. This module will generate Commodore 64 assembly code in just a few clicks, so you can spend your time thinking about the guts of your program, not the setup. The generated code is then copied into your favorite text editor, such as Notepad, and assembled using the tool called TempCross by the demo group called Style. The assembled file can then be run on your Commodore 64 computer or your favorite emulator. Let's start by creating a new folder to store your code and the TempCross assembler. Next, I'm going to copy TempCross to the folder. The link to download TempCross can be found below. And now, I am creating a little batch file to quickly automate the code assembly. This batch file isn't mandatory but does help make your coding session a bit easier. This batch file does the following. It ensures Windows is pointed at the current folder. Next, it assembles the source code using TempCross. Our source file name is going to be source.txt. The C64 binary that it will generate will be called output.prg. The final line will launch an instance of Vice emulator. You can add this line to your batch file, but keep in mind you will have to adjust the path for where your instance of Vice is located. Okay, let's create a text file called source.txt and save it in this folder. All of the requirements are now in place. Let's code. Load your favorite browser and head to www.retro64.ca. Hover over TurboCoder 64 and select Code Builder from the menu. Let's go over each line. The first option is to add a basic line. Typically, we must load a C64 assembly program by typing load program name 8,1. We would then type SYS and the start location of the code. By adding the basic run line, our user can simply type load program name 8 and then type run. No need for them to remember the start location of the assembly code. Let's check this box for our sample project. Keep in mind, you cannot store graphics or other code at hex 0800 or it will overwrite the basic run line. Next, we have to pick where in memory our code will reside. The code builder defaults to hex 4000, but we can change this if required. We will leave it at hex 4000 for now. The next line reads setup for screen splits. Games and demos will use screen splits to sync music, display multiple types of graphics at the same time such as both text and bitmap, toggled between high residential and multicolor, or use more than 8 sprites. Let's leave this box checked. The next two lines relate to handling a custom character set and changing the value of hex D018. We are going to use the built-in C64 character set for this project, but in the future when you're using your own character set, this is where you specify the file name and where in memory location it will load. Your custom character set will need to be in the same folder as TempCross. The screen RAM lines allow you to load block of text or characters into memory. By leaving the default value of 0400, the text will appear directly on screen as the program loads. We are not going to specify a file name for this project. In the future, you can specify the file name of a game's title screen. Then later on, you can copy and paste the generated code to add in a game over win screen and a game over lose screen in just a few seconds. The next two lines will add color to your screen if you have any text displayed. Again, we are going to leave the file name blank for this project. The next two lines of the code builder allow us to specify a sprite file name as well as dictate where in memory they will be located. Again, we will leave the file name blank for this project. The next 4 lines relate to playing music. You can use a tracker to create your own song or download your favorite from the High Voltage SID collection. The link for HVSC is below. Keep in mind, you will need to extract the C64 binary from the HVSC file. For now, keep the music file name blank. We do have a sample demo available for download on our website, which incorporates each of the file types above so you can see how TempCross adds them to the final file. The link is in the description below. As well, there are links to some good character set and screen text editors to help you make your own program. Okay, here's where things get really fun. In the boxes called Split 1, Split 2, and Split 3 we can add our own custom C64 assembly code. We can also use some lazy fuzz code. In the Split 1 box, let's type the following. Does your code match what's on the screen? If not, fix any mistakes. This is normal C64 assembly. Now, let's do lazy fuzz assembly in the box called Split 2. Check your code against what's written on the screen. The code in Split 1 box will split the screen near the top and change the screen and border color to dark gray. The code in Split 2 box will split the screen near the bottom and change the screen and border color to black. There are a few other keywords you can use if you don't want to type C64 assembly. Let's leave the Split 3 box empty for now. You will note in a few minutes that the code builder will generate the necessary code to split the screen in two places. You can use 1, 2, or all 3 boxes and the code will automatically adjust the IRQ pointers as needed. Moving right along. Let's press the check mark for CPU detection as well as clean the screen. Now, let's press the check mark for 1x2 scroller, but not 1x1 scroller. This will demonstrate how the code builder can quickly insert a variety of routines into your program to quickly get you going. The next 2 boxes allow you to specify a scroll text file name and specify where in memory it will be located. If you have used the 1x1 or 1x2 scroller in your project, you will find a variable within that code chunk that points to where your scroll text is located in memory. Ensure it matches the memory location noted here on the code builder, or you will see garbage or even nothing at all. Next, check both boxes for joystick port 1 and joystick port 2. This will insert some simple joystick detection code into your program. You will still need to code what happens when the user presses a direction or fire button. Let's also click the memory copy routine checkmark. Every good game or demo will need to move some graphics or code around on the fly. Let's also click the check mark for the chart showing beginning address of each text line. This chart is very handy for looking up the memory location of different text line numbers. And finally, let's generate some sign data. Under number of points, type 80. And under amplitude, type 40. Our project isn't going to do anything useful with the above data, but entering these values will help you understand how the code builder works so you can use them for your own projects. Sine and cosine generate 2 different patterns. If you require advanced patterns, you can use the Fuzz Bouncer tool on our website and copy-paste that data into your project. Review your screen and ensure it's the same as ours. Okay, let's go ahead and engage the TurboCoder. Click the large gray button. And just like that, your code is generated. Let's review it. The first chart shows key screen memory locations. 0400 corresponds to the top left corner of the screen. 07C0 corresponds to the bottom left corner of the screen. These are typically the addresses you will use when specifying which screen line to put your scroller routine on. Next, you will see the code for the basic header. In this case, the code will generate a basic line that says 10SY-S16384. This is calculated based upon where the main code begins. If we specified the code be placed at hex C1000, then the run line would say 10SY-S49152. Very cool. Moving along, the next bit of code sets up the screen splits, and also create a little loop waiting for the user to press the spacebar. Space will exit our program and reset the computer. Next, you will see two chunks called IRQ1 and IRQ2. This is where we split the screen and change colors. Following the two IRQ chunks, we will see the setup routine. Here is where the clean the screen option and CPU detection take place. The first loop, around the text of setup 1, will change the screen color to black and print a space to every location of screen memory. The next bit of code will text if the user is running an NTSC machine, a PAL machine, a Super CPU, or an Ultimate 64. You can use this to take advantage of turbo modes or to adjust timing of routines for different regions of the world. This whole setup routine will happen automatically as one of the very first lines of generated code will call it. The next two routines are our joystick routines. You can call these in the future by typing JS or Joy1 to detect joystick 1 or JS or Joy2 to detect joystick 2. Most games use joystick 2. Don't forget, you will still need to code what happens when the joystick is pressed in a certain direction. Next is the memory copy routine. By default, the code will copy code from hex 8000 to hex 2000. It will stop when it reaches hex 8400. The next chunk of code is the 1x2 scroller routine. And finally, under the Sinus Data label, we have the bit of Sinus data that we generated. Very cool. The bones of your code are complete, and we've only spent a few minutes on this. Next, highlight all text on the page. If you're on a Windows computer, simply hit Ctrl and A. Next, copy it. If on Windows, just hit Ctrl and C. We're now going to go back to our source text file. Browse to the location of the folder you created a few minutes ago and open source.txt. Paste the code into the text file. Now, save the file. We are almost done. If you created a batch file, you can now double-click it. It will assemble your code with temp cross and generate a C64 file. A temp cross window will open and we can watch it work. When it's done, we can open the file on our C64 or in an emulator. You are now ready to flesh out the rest of your code into the next viral game. Thanks for watching.